All right, so this week we're going to talk about two concepts, infinite geometric series, and we're going to talk about something called the binomial theorem. So today we're going to talk about infinite geometric series. So an infinite geometric series, it has an infinite number of terms. So has an infinite number of terms. So the first thing we want to identify is it a convergent series or is it a divergent series? Because if it's a convergent series, you're able to actually get the sum for the actual series itself. But if it's a divergent series, you're not allowed to. So I can sort of explain that to you momentarily. So it says if it's a convergent series, what you're going to find out is ratio, so that's our R value. So the absolute value of R is less than 1. Okay, meaning sort of think of it like a fraction. Or another way of thinking about that is the value is going to be between -1 and +1. Okay, and for a convergent series, what that means is that the sum is a specific number. Specific. So like 2 or 4 or whatever, negative. If it's divergent, though, what you're going to find out is that the absolute value of the ratio, the R value, is going to be greater than or equal to 1. So 1 or greater would be divergent. And if that occurs, then that means the sum goes to positive or negative infinity, which we know has no value to it, which means that there is no sum, because you can't put a certain number on those two particular values, infinity or negative infinity. All right, so the first set of directions, the first thing you always want to ask yourself is when you're being asked to determine what the actual sum is, you have to first of all figure out, can you do it? Because some cases you may not be able to. All right, so example number 1 says, determine whether each infinite geometric series is convergent or divergent. So it 100% comes down to the R value. So in order to determine the R value, you take the second term and you put it over the first term, 36 over 54, and you reduce, and we get 2/3. Well, 2/3 is definitely less than 1. So 2/3 is less than 1. So this would be a convergent series. Okay, and you're just identifying that. You're not actually finding it out. The second one is we have R equals, we take the second term and we put it over the first term, and we find out that 3/2 is larger than 1, which means that this is a divergent series. And for C, for R, we put the second term over the first term. You can reduce that. We still end up with 3/2. So same as B, 3/2 is greater than 1. So this is another example of a divergent type of series. Okay, so now where this leads us. So if it is a convergent infinite geometric series, again, infinite means it has no end to it, so you're just going to see ... Then there's actually a formula that we can use to calculate what it is. So the value we get, S for sum, is equal to A1, that's our first term, over 1 minus R. That actually took part of the formulas that we learned last week in terms of geometric, and just sort of took some things away from the numerator. But it's the first term over 1 minus R. But the key is you have to make sure that you are first identifying whether it's convergent or not, because if it's not, you just stop. All right, so example 2 says find the sum of each infinite geometric series if it exists. So again, you need to check. So for R, we're going to take the second term and put it over the first term. We have a fraction going on here, so what we need to do is we have to pull up that denominator, move it to the top, so we get 12 over -4, which gets us -3. The absolute value of -3 is +3, and that's greater than 1, which means this is a divergent series, which means that the sum does not exist. Sum does not exist. And explaining why it doesn't exist is just like that. Identify the R, identify it as a divergent series, and you can therefore say that the sum does not exist. All right, next one. Same set of directions. We're still focusing on identifying what the actual sum is. So we're going to we need our R value. We take our second term and we put it over our first term. In this case, the extra fraction's in the numerator, so I'm going to move that guy down. So I end up with -3 over 6, which is -1/2. Well, the absolute value of -1/2 is +1/2, and that is less than 1, which means that this is a convergent series, so we're good to go. So we can find the sum. So the sum formula is A1 over 1 minus R. Well, A1 is the first term, 3. 1 minus R is -1/2, right? Yeah. Yep, -1/2, sorry. So that double negative makes a positive. 1 and 1/2 makes 3/2. So you have 3 over 3/2. That extra fraction is in the bottom, so we got to move that 2 up. And we end up with 6 over 3, which when we reduce that, we end up with the sum of 2. So the sum for that particular series is going to be a nice number of 2. All right, so the sigma notation, it could be used to represent infinite series. So the infinity symbol, all right, so it's sort of like your sideways 8. It's placed above the sigma symbol. So instead of having a number up there, which we've had all along for arithmetic and geometric, now it's going to be this infinity sign above. So we're going to indicate to figure out what the actual sum is or what the series is. All right, so first thing we want to know is R. Well, R is always the value that is being raised to the exponent. So R is equal to 3/4. 3/4 is in fact less than 1, which means we are on a convergent path, so we're good to go there. Okay, in order to figure out A1, that is where we take this bottom term here and we are subbing it into the formula. So A1 is 12 times 3/4 times K minus 1, or 1 minus 1. Well, 1 minus, sorry, just going to rewrite it here. So we get 12, then we get 3/4 now to the 0. Anything to the 0 is 1, so we end up with the first term being equal to 12. So the sum would then be A1 over 1 minus R. Well, 1 is 4/4. 4/4 minus 3/4 is 1/4. And if you have 12 over 1/4, that 4 has to come up, and you end up with 48 for your sum. Could the sums be decimals? Could they be fractions? Absolutely. Just always make sure that you're double checking the math and making sure that you're getting the correct value for your